Long division with two-digit divisors and no remainders. In this lesson, you will compare the expanded notation method for division to long division, and you will practice using long division to divide four-digit dividends by two-digit divisors. Let's begin with the problem 3,484 divided by 26. Just like when we worked with one-digit divisors the other day, we're again going to be trying to figure out with expanded notation 26 times what number gets us close to our dividend 3,484 without going over. Then when we look at long division, we'll be following the same concept, but instead of looking at the place values like we do with expanded notation, thinking about 3 as 3,000, we're going to think about digits and thinking about 3 as simply 3, 4 as 4, 8 as 8, 4 as 4. So let's begin. Looking at the first problem with expanded notation, we follow the same process. We're thinking about 26 times what number will get us close to 3,484 without going over. To help me think through this, I'm going to think about 26 in relation to 25. 25 is an easy number for me to multiply by, so I'm going to keep that number in my head as I'm trying to figure out what my partial quotients might be. So as I look at my dividend, 3,484, I have 3,000 and then I have 400s and I see 34 there. And I know that 25 or 26 can go into 34 one time, but I know that this is not 34, it's 3,484. So I don't want to do 1 for my partial quotient, I want to use 100. So I'm going to do 100 times 26, which equals 2,600. And we subtract. And once we finish subtracting, we are left with 884. Then we repeat the process. So 26 times some number that gets us close to 884 without going over. Looking at 884, the first two digits I see are 88. Thinking about 25, I know if I skip count by 25 3 times, that's 75. If I skip count by 25 4 times, that's 100, or in this case, it will be 1,000. So I know that I can make at least 3 groups of 25 out of 88. But again, this is not 88, it's 884. So I don't want to multiply by 3, I want to multiply by 30. So I'm going to do 30 times 26. Now, if I don't know what 30 times 26 is off the top of my head, then I simply write it to the side and check it. So 26 times 30, I know that 3 times 6 is 18, and 2 times 3 is 6, plus 1 more is 7. So that's 780, which is pretty close to 884. So I'm going to subtract 780. And then once we subtract, we'll see what we have left and keep dividing as needed. So we're left with 104, and 26 in relation to 104 is not a lot smaller than 104. And I know that 25, if I skip count by 25s, 25 would be 25, 50, 75, 100. So I could possibly make 4 groups, but I know that I went rounded down 1. So if I think about that, since I only went down 1, that probably accounts for these 4 ones extra. So I'm going to check 26 times 4 and see what that equals. So off to the side, I'm going to solve 26 times 4 to verify if that works. I know that 6 times 4 is 24, 2 times 4 is 8, plus 2 more is 10. That's a perfect match. So I can make 4 more groups of 26 out of the 104 that's left. So then I subtract, and we have nothing left. Again, to find my partial quotient, versus my total quotient, I add my partial quotients, which equal 134. Now, let's repeat the process, but this time looking at it from the lens of long division. So the other day we looked at how expanded notation and long division are very similar. So I want to focus on that again today as we look at these two strategies. And I want you to pay attention to how the digits in our partial product or partial quotients here are similar to the digits that we'll end up with in our quotient for long division. I also want you to pay attention to how the digits in the beginning of our amounts that we're subtracting are similar to what we subtract over here. So let's walk through it together. Now, as I told you the other day, when we were dividing with one-digit quotients, I was starting with the first largest digit in my dividend and asking myself if I could make groups of my divisor out of that digit. Now, we have 26 and our first digit is 3. Obviously, we cannot make a group of 26 out of 3. So when we are working with two-digit divisors, we've got to start out by looking at the first two digits. So I see 34 here, and I know that I can make one group of 26 out of 34. And since we are pretending that this is just 34, this is our shortcut. Since we're pretending this is just 34, I'm going to simply put a 1 in my quotient, and I'm going to multiply as if this is just 1. 1 times 26 is 26. I subtract, and then we are left with 8. Okay, and then I have to bring down the next digit. Now, comparing right here, the amount we subtracted, we see 26. Those are the first two digits in our expanded notation. We're ignoring these zeros here. Then in the amount that's subtracted, we see 88. That's the first two digits in what was left over when we subtracted the first time in expanded notation. All right, so next step, I'm repeating the process. I'm asking myself, how many times can 26 go into 88? I can think about 25 again to help me think through this. I know that 25 times 3 is 75, but this is not 25, it's 26, so I need 78. So 26 times 3, if we check it to the side, 6 times 3 equals 18, 2 times 3 is 6, plus 1 more is 7, so I'm going to subtract 78. When we do that, we're left with 10, and I have to bring down the next digit. Now I'm asking myself finally the last step, or actually before we move to the last step, let's compare. So we said that 88 matched. Now we see that, that 78 matches as well. We see 78 in the first two digits of 780. And then this 10 that was left over matches, it's the first two digits of 104. So now we bring down our 4, and then we repeat the process, asking ourselves, how many times can 26 go into 104? I can think about 25 to help me work through this. I know that 25 times 4 is 100, so 26 times 4, as we said over here, is 104. So I'm going to do 4 groups of 26, which is 104, and we have no remainder. So our answer is 134. So these are essentially the same steps once again, but we're ignoring the actual values of these amounts. So we don't have our zeros in when we're using long division. We're ignoring those zeros here. Your turn. Pause the video to try the next problem on your own. Then, once you have finished solving, continue the video to check your work. Now that you've had a chance to solve this problem, let's walk through the problem 1974 divided by 47 together. As we walk through it, I want you to check your work on your piece of paper and make sure that it matches the work that I'm showing you. All right, so with this problem, our divisor 47 is only 3 digits away from 50, and 50 is an easy number for us to think about as we are multiplying and trying to figure out what our partial quotients are. Looking at our divisor 1974, I see 100, or actually I see 19 to start with. And normally we look at the first two digits, but in this case, 19 is less than 47. So I need to look at 197, these first three digits, and think through that as I'm working. So I know that 50, if I skip count by 50, I know that I have 50, 100, 150, and then I have 200. 200's probably, or four groups of 50 is probably going to be too much. However, we did round down, or excuse me, we rounded up to 50. So when we're thinking about the actual answer, 47 is less than 50. So 4 might work. So in this case, we want to check 4 and see if that's a possibility. So I'm going to see what 47 times 4 is. So I know that 4 times 7 is 28, and 4 times 4 is 16 plus 2 more is 18. 188 is less than 197. But what I have to remember is that this is not 197, it's 1,974. So I don't want to multiply by 4, I want to multiply by 40. So if we multiply by 40, this will be 1,880. So we're going to subtract 1,880, and we're left with 94. Then we repeat this process. So again, figuring out 47 times what number will get me close to 94 without going over. I know, thinking about 47, if I double 40, that would be 80. If I double 7, that would be 14. 80 plus 14 would be 94. So I can make two more groups of 47 out of these 94 pieces that we have left. So 2 times 47 is 94. I subtract, I have nothing left. And again, we find our quotient by adding our partial quotients. 40 plus 2 is 42. Now, looking at this through the lens of long division, same process. I can think about 50 to help me reason through it if I need to. And I'm not thinking about these digits in 1,974 as what their actual values are worth. I'm going to start by looking at the first two digits. Again, I have 19 here. 19 in comparison to our divisor 47 is too small. So I've got to look at the first three digits, 197. And just like we did as we reasoned through expanded notation, just like we reasoned through there, I can think about 50 and say, well, I know that 50 times 4 is 200. So 47 times 4 will get me close to 197 without going over. And just like we checked the first time, 47 times 4 gives us 188. Now, this time we're going to use it as 188 because we're pretending like this is 197 instead of 1,974. And so we'll subtract. And we're left with 9. And we bring down our 4. Then we repeat the process. 47 times what digit will get us close to 94 without going over. Notice this is the exact same problem now. 94, 94 divided by 47. And notice that in the step before, we have 188, which are the first three digits of what we subtracted in expanded notation. We just ignored this 0. Now, we know from our previous work that 47 can go into 94 2 times. So 2 times 47 is 94. We subtract, we have nothing left. Our answer is 42. There's no addition step needed in our quotient because we wrote it as digits instead of as place values or actual values of each place. All right, try another example. Pause the video again to attempt the next problem on your own. Then, once you have finished solving, continue the video to check your work. All right, now that you've had a chance to solve the problem, let's walk through it together again. This time we're looking at 1,216 divided by 32. As I'm walking through expanded notation, once again, I'm asking myself 32 times what number gets me close to 1,216 without going over. I'm thinking about 32 in relation to 30. 30 is an easier number to think about when trying to figure out what my partial quotients could be. Now, to help me reason through, I'm gonna think about 12 first. I see 12 is smaller than 32, so I'm gonna think about 121. 121, that makes me think of 120. And I know that if I skip count by 30, I'm gonna say 30, 60, 90, 120. So 4 groups of 30 is 120. However, our divisor 32 is bigger than 30, so 4 groups will not work. I'm going to need to adjust and bump it down 1. So I'm going to work with 3. But I know that this is not 121, it's 1,216, so I don't want 3, I want 30. And then I'm going to check that to the side because I don't know off the top of my head what 32 times 30 is. I know that 2 times 3 is 6 and 3 times 3 is 9, so that's 960. So I'm going to subtract 960. And I'm left with 256. And then we repeat the process. 32 times what number will get me close to 256 without going over? I can use 30 to help me reason through that. So I'm going to skip count through by 30s again and use that knowledge to help me. So 30, 60, 90, 120, 150. That's 5 groups so far. Then we have 180, 210, and then 240. So that's 8 groups. I know that 30 times 8 is going to be 240 groups, or 240 pieces, not groups. So since I know that 32 is 2 more than 30, I'm going to try 8. I'm going to do a little bit of guessing and checking. So I'm going to say 32 times 8 and see what that is. I know that 8 times 2 is 16. So far that matches. And then 8 times 3 is 24, plus 1 more is 25, which is a perfect match, 256. So I can make, out of 256, I can make 8 more groups of 32. So 8 times 32 is 256. We subtract, we have nothing left. We add our partial quotient to get a total of 38. Now let's look at this again with long division, focusing on how these are similar. I'm going to again think about 30 to help me reason through this. I'm focusing on the digits, so I'm thinking about this as if it is 12 or 121. So I see again 12 is less than 32, so I need to look at the first 3 digits, 121. And I'm going to think, well, I know that 30 times 4 is 120. But this is 32, not 30, so I need to use 3 groups. And I'm going to check, what is 32 times 3? I may not know that off the top of my head. 3 times 2 is 6, 3 times 3 is 9. So I'm going to subtract 96. And we're left with 25. Notice that 96 is the first 2 digits of 960 in our expanded notation. We ignored the 0. 25, the amount that's left over, is the first two digits in 256, the amount that was left over in our first subtraction step. All right, now, once we have subtracted, 25 is less than 32, so we bring down the next digit, 6. We have 256. That's an exact match to what we had with expanded notation. Now I'm going to think through again. 30, how many times could 30 go into 256? Well, if I skip count by 30, 30, 60, 90, 120, 150, 180, 210, then 240. That's 8 groups. And I know that 32 is 2 more than 30, so 8 would probably work. 32 times 8, I'll check. 2 times 8 is 16. 8 times 3 is 24, 25. 256 is a perfect match. So I know I can make 8 groups of 32, which is 256, and I subtract, I have nothing left. 38 is my answer. In this lesson, you compared the expanded notation method for division to long division, and you practiced using long division to divide 4-digit quotients by 2-digit divisors. And that should say 4-digit dividends. I forgot to change it. Thanks, guys.